Hello students, our next topic is EMF. Now EMF is the potential difference offered by a cell. So it is simply the potential difference between the terminals of the cell when the cell is not in use, and we can measure it with the help of a potentiometer or with the help of a voltmeter, directly connecting the voltmeter with the two terminals of the cell. And then comes the terminal voltage. Terminal voltage is defined as the potential difference between the terminals of the cell when the cell is in use, means when we are drawing current from the cell. Now there are some other definitions also in terms of the work done. So in terms of work done, EMF is defined as the work done in taking a unit positive test charge throughout the whole complete circuit from one terminal to another. When we say complete circuit from one terminal back to the same terminal, it means the work done in taking a test charge from positive terminal to the negative terminal through the outer circuit, and then from the negative terminal to the positive terminal through the electrolyte. It takes the complete round. So that work done per unit charge is called EMF. Terminal voltage in terms of work done is defined as the work done in taking a unit positive test charge through one terminal to the other. It means only through the outer circuit. So if W is the work done in completing a complete round, then EMF will be W upon Q. And here W dash represents the work done in taking a test charge from the external circuit only, outer circuit only. Then comes the third term, voltage drop. Now voltage drop is that potential difference which is not available to the outer circuit. It is dropped inside the electrolyte only. It is left somewhere. That's why the word voltage drop has been chosen. So voltage drop is the work done in taking the unit positive charge from one terminal to another through the electrolyte. So that work done, which is done only in the inner circuit. Inner means through the electrolyte. That is called that is the cause of voltage drop. It means if total work done outer and inner circuit is W, only outer circuit is W dash, only inner circuit is W small, it means this work is the sum of outer plus inner work done. So if I divide the whole equation both sides by Q, which is the test charge taken, then I will get this equation. Now from my definitions of EMF, potential difference, which is also called terminal voltage or simply potential difference, and the voltage drop, I will get from this equation this relation using these three equations 1, 2, 3. So EMF is the sum of terminal voltage and voltage drop, or I can say voltage drop is the difference of EMF and terminal voltage. The next term is internal resistance. As I know that Ohm's law tells me V is equals to IR. Similarly, for the voltage drop, V is equals to IR. But here this small r is called the internal resistance of the cell, which is actually the resistance offered by the electrolyte to the flow of charges through it. Then next article is relation between E, V and R. EMF, terminal voltage and the internal resistance. Now a cell which has some appreciable internal resistance, it can be represented like this. Simply a cell without internal resistance is represented with this symbol, and a cell with internal resistance is represented with this symbol. Right? Dotted box, cell along with the resistor. This box tells us that this resistance is belonging to this cell. Now this is an external resistance. If I connect an external resistance with a cell, then the total resistance of the circuit will be R plus R. I know that current is equal to EMF upon total resistance. This is my knowledge of Ohm's law tells me. So I becomes E upon R plus R. this equation tells me EMF is I into R plus R. Now, similarly, Ohm's law tells us that terminal voltage, which depends upon the outer circuit only, it will be equal to I into capital R. Voltage drop will be equal to I into small r. It means from these three equations I get this result again, which I got from the works equation also, that EMF is the sum of V plus small v, because if I open this bracket I will get this, and this is capital V, this is small v. So again I'll get the same results, and if I want to find out internal resistance, it will be small v upon I. Substituting the values, I will get this result. So if you know the basics of EMF, you can solve any numerical and you can reach to any of these relation there and then. The next articles in our books is combination of resistors. Now, combination of resistors, derivations have been removed from the syllabus, but I am here telling you the derivations for your proper understanding. What happens? There are two kinds of combination of resistors. One is series circuit, where the resistors are joined end to end. Now, when I combine such a circuit with a battery through a key, current starts flowing because they are joined like this, like beads in a string. So the same current will flow through all these resistors. But if battery has given potential difference V, here potential difference means terminal voltage. If battery has terminal voltage V, it means that it will be the difference of voltage between VA, this point and this point. This point is at higher potential being connected to the positive of the battery. This point is at lower potential because it is connected to the negative of the battery. That's why the current is flowing from this point towards this point. Now, here I want to tell you that current flows from this side to this side because every point has got higher potential than the next point. So, VA is greater than VB. Potential of B is greater than potential of C. Potential of C is greater than potential of D. It means that the three resistors have different potential difference always. So, in series circuit, I remains same because it has got the same path to flow, but the potential difference, the total terminal voltage, gets divided into the three. So I can write here, these are the two equations. I remains same and V becomes equal to the V1 plus V2 plus V3, that is the sum of the three voltages, where these voltages are VA minus VB, VB minus VC, VC minus VD, and the net voltage is VA minus VD, higher to the lower. And if I apply Ohm's law to all these three, then V1 will be equal to I into R1 because I current is flowing through this. Similarly, V2 I into R2, V3 I into R3, and total V will be equal to I into the total resistance. Now, what is the equivalent resistance of the whole circuit? I have chosen a symbol RS for that. If RS is the equivalent resistance, the total voltage will be equal to I into RS. So substituting this value and all these values in this equation, we will get this result. Here I comes out common and it gets cancelled out. So net resistance in series, this is the result which we have to use and which we have to learn now. Derivation is not in your syllabus, but you should know the understanding of it. Then if there are n resistors, there are more than 3 resistors, then they simply get added up. Their values get added up to Rn. N means any number. It may be 15 resistors, 10 resistors, any number. And the second result is that if all the resistors are equal, let us say equal to R, then R plus R n times it will become NR. So net resistance in a series circuit, it increases. Series में resistor इंक्रीज हो रहा है, बढ़ रहा है. नेक्स्ट कॉम्बिनेशन इज पैरेलल. Now what is a parallel circuit? Parallel circuit means a battery is connected to 3 resistors, let us say R1, R2, R3, but all 3 are connected between the same 2 points A and B. Now the potential difference of these 2 points will be equal to the terminal voltage, right? But all three are between these 2 points, it means all three will have the same potential difference. So in parallel, V is same. Let us talk about current. If I current starts flowing from here, then at this junction it gets divided into I1 plus I2 plus I3. And at this junction it again combines, and outer circuit again I current is flowing in this main line. Then it means in parallel we start with the discussion of I is equals to I1 plus I2 plus I3, and we will apply Ohm's law in each of the arm. Now I am interested to find out the potential difference or the current if I3 and R3 are given. V is potential difference is V, then I3 will be V upon R3, I2 will be V upon R2, I1 will be V upon R1. And if Rp is the equivalent resistor, if I am saying total resistance of this circuit, let us say is some value Rp, then total voltage is V, total current is I, so it will be I will be V upon Rp for the net resistance. So I will substitute I's value here and I1, I2, R3's value. V will be taken out and cancelled out. So net resistance result is this. It means in a parallel circuit, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistors. And always remember that in a parallel circuit, the net resistance of the circuit decreases. It means the value of Rp is less than even the least resistance connected in the circuit. If you connect to 100, 111 and 111, three resistors you are adding in parallel, then the answer will be less than 1, right? So its answer is always less than the least. Next results are, if there are n resistors, you will keep on adding one reciprocals like this up to Rn. And if all the resistors are equal, you will get 1 by R, 1 by R, 1 by R, 1 by R. It means n times 1 by R. So 1 by Rp will be n times n by R. But we are interested in the result, not the reciprocal. So result Rp will be R by n. R by n means it is getting reduced by that factor. So again this result tells us that the net resistance decreases. One more formula very commonly used in numericals is where two resistors are added in parallel. When two resistors are connected in parallel, their net resistance will follow again the same formula. You just solve it out. Taking the LCM, you will get this result. But this is 1 by Rp. So what will be Rp? R1 R2 upon R1 plus R2. So this is a shortcut for two resistors. You can just apply this formula when two resistors are in parallel. Just product of the two divided by the sum of the two. You will get the result very quickly. Like R1 is 2 ohm, R2 is 3 ohm, and Rp will be 2 into 3 6 upon 2 plus 3 5, that is 1.2 ohm. Again the result is less than 2 ohm, that is less than the least resistance connected. So this was all about combination of resistance. After this we are able to solve the numericals. Thank you so much.